The project I'm trying to make today is sort of a replica of GarageBand. It's a place where you're able to mix and match music and then replay it in the order you like, hopefully being able to create your own beats and rhythms. The program I have works like this. There are 13 memory addresses where tunes can be saved. Each tune has a duration and a frequency. The duration is specified by how long you hold down the record button, and the frequency is specified by what setting the potentiometer is set to. Each tune has a sequential order, starting from 1 to 13. It can be played back with the playback button. Also, you can set the potentiometer to its lowest setting if you would like to record no sound and only a pause duration. Switching through which tune you're editing can be done with the use of 4 slide switches, which are represented in binary. The binary slide switches can represent any number from 0 to 13, with 0 being reserved for not recording anything and only for testing purposes. Let's start wiring the circuit. The first thing we're going to need is a piezo buzzer. That's what's going to be making our actual noise. We'll connect that to 5 volts and ground. Next, we'll need our slide switches. We do the math quickly to ensure that we have enough number of memory addresses with our 4 slide switches. Then we figure out a configuration that's needed to connect them to ground and 5 volts, and then finally to our digital pins for reading. Next, we connect our potentiometer to our analog input pin and connect that to 5 volts and ground. Finally, we're adding our 2 buttons, our record button and our playback button. These buttons are going to control the entire operation. After that, we add the LEDs. The LEDs show which slide switches are on and which are off for easy identification. Let's test our circuit. First, we test the piezo buzzer. We can see that it's working because of the radio wave signals coming out of the piezo, which represents the sound. Next, let's test the slide switches. We can see that the LEDs are getting too much current. This is because we forgot to add resistors. Let's do that now. Okay, let's go ahead and test our LEDs again. Starting the simulation and turning one of the slide switches on, we can see that the LEDs no longer burn up with overcurrent and glow properly. We also verified that we're getting the correct input from the slide switches. Let's continue to test all the other slide switches. We can see that when we flip the state of the slide switch, we get a reading of 1 and the LED turns off. When we flip it again, it goes back to 0 and the LED turns off. This means that the slide switch is working. This is working for all of the slide switches and LEDs. Next, we check the input from the 2 buttons, the record button and the playback button. They both seem to be working. Finally, we're going to check the input from the potentiometer on the analog pin. That also seems to be working, giving us a range between 0 and 1023, as expected from an analog pin. Okay, let's try and make a beat. The beat I want to make is a simple beat. It has 2 low frequency bursts, a pause, and then 2 high frequency bursts. So let's get started. First, let's activate memory address number 1. Or rather, let's first start the simulation, then activate memory address number 1. Also, what you're seeing on the serial monitor here is the duration for each memory address. Right now it's 000 and so on because no data or no music has been recorded. But once we start recording, it's going to show the duration of each memory address, and this can be easily changed to instead show the frequency. However, I thought it'd be more helpful to see the duration since you can understand the frequency based on the potentiometer, but you have to remember the duration based on how long you held the button, which is much harder to do. So let's get started. Our first low frequency maybe should be around here, and let's go for around 90 to 100 milliseconds. Okay, so 91 is not bad. Now we switch over to our second memory address and want to replicate the exact same thing. Let's try it again. A little high, but close enough. Now let's go ahead and give our pause. The way we give a pause or no sound is by simply turning the potentiometer all the way down, and then choosing our memory address as always, and then just holding down the button for however long we want the pause to be. You should notice that you're not going to hear any noise, but the duration is being recorded. So it's being recorded even right now, and when I let go, you'll be able to see that it shows up here. And that's kind of long. Maybe we don't want it to be that long, so let's try to shorten it. So it's being recorded right now, and when I let go, 300 is more reasonable. So let's use that. And now let's activate our fourth memory address and turn these two off. That gives us our fourth memory address, and now we want a higher pitch or higher frequency note. And we're still trying to aim for the 90 to 100 millisecond range, though. 100 is okay. And now we switch our slot. We want to move one up, and let's do it again. A little high. Maybe we can get it better. Too low. No. No, definitely not. Hmm. A bit tricky. But we definitely don't want the numbers that high because it's just not going to be consistent. But I think 107 is right now just the kind of range I'm clicking in. So let's go ahead and hear the playback of this. So did you notice how those two low frequency beats and then a pause and then those two high frequency beats? Because that's what we told it to do in our memory. Let's go ahead and hear one more time. So it's like the two low grumbles, and then a pause, and then the two high chirps. Final time. Okay, so that's how you make music, and that's how you order it, how you edit it. And remember, if you wanted to edit any part of this, we could always go back. Like, let's say we wanted to change how long this duration was. Let's say we think it's a little too long. It's on memory address number 3, so we just turn this off. We go back to here, and now we're back to editing memory address number 3. We just slide it back down, specifying that we want no sound. And let's try to see if we make it a bit shorter than 300. Okay, there we go. Now it's 108. So if we now hear playback again, you'll notice that the duration, the pause is much shorter. Okay, so hopefully you notice that. And you can edit any part of it. And remember, we've only done 5, right? 1, 2, 3, 4, 5. Yep, 5, including the pause. We've only used 5 memory slots. You can use up to 13. You can see all the blank ones over here to the right. Okay, so that's how you use the program. Okay, so let's go ahead and walk through the code. So first of all, this code, there's very few parameters adjusting the code because a lot of it is done on the circuit itself by adjusting the potentiometer and the slide switches. So the two things that we do have, however, is the delay between notes, and that's the default delay. Even when you don't manually set it with the potentiometer, how much delay there is between notes, and by default that's 200 milliseconds. And basically, what that means is how much time passes before you play the next note in the memory address series. The next one is memory address display. This is just for debugging. So on the serial monitor, it's going to show you either the frequency or the duration. By default, it's the duration, and if you change it to false, it's going to be the frequency. So right over here, when it's true, it's going to show you the duration for each memory address, and when it's false, it's going to show you the frequency for each memory address. Okay, so that's all the parameters there are. They're very simple. Because as I said, most of it is controlled on the circuit itself. Next, we just have our pins and we declare them here. Um, this is actually holds which memory address we're currently modifying, and it's calculated based on the binary slide switches. And this just checks if we're modifying anything at all, just basically saying if it's 0, then we're not modifying anything. If it's anything besides 0, then we're modifying some memory address. This stores the frequency for all the tracks, and this stores the duration for all the tracks. So instead of having a multi-dimensional array, it's 2 separate individual arrays. Then we have frequency, which is going to store the frequency for each track. So that's calculated based just by getting the potentiometer value and adding 100. You'll see below. And then start time is used to help calculate the duration. These pins, you should see an old tutorial, my last tutorial specifically, but they're basically used to check when a button has been pressed. So a state change, so it's gone from off to on or on to off, and that's why we need to record old values. Over here we have, so these are the parameters, we already discussed them above. This is an exponent function. I had to make a custom one because the built-in one tried to approximate things. So for example, it said 2 to the power 2 is 3. So I had to build my own custom one, and it just basically uses a loop to go through and multiply the base the number of times, as you would, that's just how an exponent works. Like you take the base and you multiply it, that the number of times as you're putting into the power of. So that's what this loop does, and then it just returns it. And of course, it has a special case for 0 where it just returns 1. Okay. So here in the setup, we're just going to declare all these inputs and outputs, and then except for the slide switches, which we declare separately. And you'll notice that they don't even have their pins declared here, just because we don't need to. The way we use them, we don't need to know their pins because they're all in a series order, so we can just use the for loop. So yeah, that's declaring all inputs, and this is going to set the default values. There are blank values for track and duration, which is just going to be 0 in all the memory addresses. Begin the serial monitor at the correct baud rate, so that's the speed of what you're reading and writing to the serial monitor. So then we get our old and new values set up here. And here is where the magic happens to figure out which memory address we're writing to. So it uses an algorithm to convert from binary to decimal or base 10. And basically, if you know how number systems work, that's exactly how it does that. And if you've converted from binary to decimal before, that's what we're doing over here. So we're taking the value of each of the slide switches, and we're basically looking at that as a binary number, and then we're converting it over to a decimal number all in this one line. And this loop, of course. We do that 4 times because there's 4 slide switches. Next, we have our frequency, which we're getting from reading the analog pin, and we're adding to 100 to it because we below 100 it's not really audible. So our frequency just starts at 100, and or it's not. It doesn't really sound the best. That's why it starts at 100. And then we have again, this is just checking the modifying. Where same thing as above. If we're actually modifying a track, and that's based on this over here. And then we have so if we're modifying something, then only are we going to change, because this entire part is only to modify the memory addresses. It doesn't do anything. It doesn't play any noise. It just modifies memory addresses. So only for modifying something are we going to be modifying something, right? Hopefully that makes sense. So yeah, so what we're going to do is if we have a state change in the record button, something is being pressed, or unpressed or let go. Then if we have that, what we're going to do is if it's being pressed on, we're going to do this bit of code over here. And if it's being pressed off, or rather let go, we're going to do this bit of code. So what this bit of code does is if it says if it's 100, which means it's all the way the frequency is 100 on the potentiometer, then instead of normally just adding just making the memory address the actual frequency, we're going to set it to 1, because 1 means something special to the playback. It means for just to play no sound and just wait for that much time. So that means something special. It's like a special case for the playback. But otherwise, all the rest of the time, we're just going to be setting it to the frequency of whatever was on the potentiometer, and then of course plus 100, because that's how we get our frequency. And then we also record start time, which is when the button was initially first pressed, because we need that to check how long the button was pressed, because we're going to use it when we release the button, which is right here in this else statement. This is upon button release, or when it's been turned off. And since it's a push button, the only way you turn something off between a state change is if you let go. So what you do is the duration is calculated by checking the current time and subtracting from the time it was first initially pressed, and that's saved track durations, and the frequency was saved to tracks. Okay, so that's all with the memory addresses. Moving down here, so this entire part is all to do with playing the actual sounds. And this bit over here is for playing it in recording mode, and this bit over here is for playing it during playback mode. Okay, so that's the first thing we ask is the playback button pressed? If not, then this is recording mode. If it is pressed, so the not of a not is a yes. So if it is pressed, then we run this bit of code over here, which is a playback code. So let's go into the recording code first. So we ask ourselves now if the playback button is not pressed, is the recording button pressed? Okay, if it is pressed, and what is the frequency? If the frequency is 100, which means the potentiometer is all the way down, we don't want to play any noise, so that the person using it knows that they're recording a blank interval of time. However, if it's any value besides all the way at the bottom, then what we're going to do is we're just going to play the tone that they have set up, the frequency with the tone on the Piezo buzzer, based on where the potentiometer was. And remember, frequency was calculated up here. And then we're also gonna if like neither of those buttons are pressed, so if the playback button and the recording button is not pressed, we want to have a no tone. So we're just gonna turn the speaker off essentially. Okay, and then we come down here. So this is during playback, and so what we're gonna want to do is we want to go through all the memory addresses to start playing them. So that's what this loop does. It goes through from 0 to 14, all the memory addresses. Technically, we could start at 1, since memory address 0 is never going to have a tune in it. But it's okay because we have this check over here where it says if it's not 0, which means it's not blank, because remember that's the default value, then only run this bit of code, otherwise do nothing, just essentially skip it over. And then we have another bit of specialized code than that that says if it's 1, just put the delay. Just have a delay. Um, don't play any noise. However, if it's not 1, if it's anything besides 1 and 0, then what we're going to do is we're actually going to play the delay, play it for a little bit of time, turn it off, and then have our wait, which is how much time we wait between playing the next signal. As soon as this is done, it's going to loop back on top of the loop and start and play the next note almost immediately. Okay, so when that's done, when you've gone through and played the entire memory address, then we just turn the speaker off. Okay, and the final thing down here is just what's printing to the serial monitor. Let me just keep it standard. It's up here. So this just prints either the duration or frequency of each memory address to the serial monitor, depending on this variable that was part of the parameters. And that's it. That's the entire program. That's how Kitchen Band, the nickname for this product, so there's no conflict with GarageBand. That's how the product works.